All right, we're on section 12.4. This is the second and hopefully last video for this section. Lana invents a new beauty product. A cosmetic company offers to pay her $124,000 per year for the next 20 years. What is the value of her invention if the money is worth 7.9% compounded annually? All right, so there are a few things from this we need to know. 124,000 per year for 20 years, 7.9% compounded annually. All right, so we want to know what is the value of her invention if the money is worth 7.9%, and that means what is the value of her invention today, right? So we're going to be solving for present value or computing present value. All right, so it's 20 years compounded annually, so one time per year, 7.9% interest and compounded once a year, so we divide by 1. We are looking for present value. Her payment is a positive because she gets to take that payment. 1, 2, that's the number of zeros, and future value is 0. All right, so we are going to be computing future value, and that means that we want to know what this number will be. All right, so when you compute the future value, it's going to be a pretty big amount because we're talking 124,000 for 20 years, right? So that's how much she's going to get for 20 years each year. And so this number, it's negative because it's put into an account, 1,226,563 and 72 cents. Right, and remember that's not what I wanted to do. Put that back. That is a negative just because that is what would be in the account. All right, so that's the answer to that one. Just always be sure you pause and see if you can get everything filled in on your own, and then compute and check with my answer. All right, so the next question is about tuition costs at a local college are expected to be $12,000 per year in 18 years. How much should new parents deposit in an account earning 5.3% compounded semi-annually to be able to pay for a 4-year degree? Well, this is $12,000 for 4 years, right? So we're trying to accumulate $48,000 in this case. And we have 5.3% compounded semi-annually, and we're going to be able to do this in 18 years. Okay. So future value is a positive $48,000. And we are not paying a payment. It's 18 years compounded semi-annually, so twice a year. So we multiply by 2 and press the equals key to put that on our calculator for n. We're dividing our interest rate 5.3 by 2. Make sure you push your equals key before you push your IY key. And we are solving for, or computing for present value, right? We're going to compute present value. I got out of that for momentarily, so there's a little weird thing happening there. We're going to compute this present value. So that's the number I'm going to circle. And it is $18,720.56. So that's a pretty good chunk to come up with. However, it's a lot less than $48,000, and that's what we're hoping that it will grow to in that length of time. right, let's look at the next example. Starbright has decided to start saving for her retirement. She's going to start the account with her tax refund of $750 and deposit $50 each month. So that's already telling us it's going to be compounded monthly. The savings account earns 4.64% compounded monthly. How much will be I'm sorry. How much will be in the savings account after 25 years? All right, so it's compounded monthly, and we're going to go for 25 years. So N will be 25 times 12, push our equals key, and then 4.64% interest. That will be divided by 12, push equals before you enter. Her one deposit for present value is $750. And then she's also making a payment every month of $50. And then we're looking for, in this case, remember we're on the practice problems, so we could do future value or present value. We are going to compute future value. And how did we know it was going to be future value? It's because it says how much will be in the savings account after 25 years. So that's definitely going to be in the future, which is future value. All right, and so let's see what that is once you calculate that on your calculator. And it is a positive 30,613.04. All right, so always make sure that you get the same thing computed. Double check your interest rate. If you're having problems, make sure that you didn't key it back in. All right, on the next question, you would like to buy a house someday and estimate you will need $25,000 for your down payment to get a good rate on a mortgage loan. You currently have $3,500 saved and can save $200 per month. That should be a comma right there. $200 per month, making a deposit every 6 months. If you found a money market account which pays 3.9% compounded semi-annually, how long will it take to save up for your down payment? So this is a question that's extending things just a little bit, because I actually ask you how long, and that means that we're going to be computing in this time. So I like to just throw some of these little things in. We can actually compute any of the keys as long as we have all the information we need for the rest of them. All right, so we're saving $25,000. We currently have $3,500. We're going to deposit $200 a month, and it's 3.9% compounded semi-annually. All right, so 3.9 divided by 2 equals, and then our present value is $3,500 because that is the amount we have at the moment. Our payment will be $1,200. I should put those on there. Now, why am I writing $1,200? Because she's going to save, or you're going to save $200 per month, but make your deposit every 6 months. So that's 200 times 6. So every 6 months, you're going to deposit your $1,200 because this is compounded semi-annually, and not to confuse, how this works. Your future value is positive because you can take that money and pay your down payment. So you get to take it out of the bank or the account, whatever kind of account you're working with. Okay, so we are going to compute N, and then we're going to do a little something else with that. When we compute, we get 14.79 periods. Now, that is 2 periods per year because it's compounded semi-annually. So in this case, we're going to have 14.79 divided by 2, which is 7.39 years. It's always better to look at this in the number of years and not just the number of periods, because it depends on how often it's compounded on how that turns out. All right, and then I'm going to show you one more with a little bit different computation. Melvin Maxwell, a 25-year-old real estate broker, decides to start his retirement plan. He figures his income for the next 40 years will be sufficient to deposit a set amount of money at the end of each quarter into his retirement plan, earning 6.5% compounded quarterly. If he would like to have $1 million in his plan at age 65, how much should he deposit each quarter? All right, so we just have to get all the numbers put in and where they go. Okay, so for 40 years, so 40 years times 4, because it's compounded quarterly, and the interest rate is 6.5% divided by 4 because of the quarterly compounding. He's not depositing any money initially, so our present value is 0. He wants to accumulate $1 million. So that's a pretty nice amount. And we basically then just compute the payment. And remember, we can compute any of these numbers that we need to. Okay, so we're going to compute and see how much money does he need to put in quarterly. And when you compute this amount, you get $1,333.58. Now that's quarterly, right? So every 3 months, 4 times a year, right? Every 3 months would be 4 times a year. So if we divide that by 3, we can see what that is monthly, which usually makes more sense to us. And that would be $444.53 per month. And then he would be able to get his $1 million at the end of 40 years. All right, so that's the end of this video. We are finished with section 12.4.